All right, welcome back, Ling 341. It's been a while since we've done one of these, but I'm going to try to walk you through the vowel matching exercise, which we did almost a month ago now, or you did almost a month ago, but I didn't really do it with you. I'm going to contribute my part now today and try to walk you through one approach to doing this exercise. I'm only going to do the first vowel matching exercise because I think the principles will apply pretty straightforwardly to the second one as well. Remember that what we did here was that we had spectrograms for these 13 different words, most of which were B, vowel, D words like bad, bod, bade, so on and so forth. And they were spoken by a female speaker of Canadian English, which has makes one minor difference in terms of how many vowels there are between the two different matching exercises. So we have 13 for this set, and I gave you spectrograms of each vowel production by this speaker of English, and from the spectrograms you were supposed to be able to figure out what the vowel is in each representation. This is not easy the first time you tried it for sure. It gets easier if you get more practice, but I'm going to show you one way which might work for you if you have to do this again for any reason. And I'm going to do it by cheating a little bit because I have the original sound files from which this exercise was made. So you guys all got the spectrogram images just by themselves. You had to kind of figure out where the formants are in each one of these and then match those up to different vowels that you might get in words like these 13 at the top of this page. I got, or since I recorded this way back when, actually have the original sound files, so we can just look at those. And I'm going to show you one approach you can take if you're unsure about this. So number one, we'll just start off with sound A here. This is going to look a little bit different from what you see in these spectrograms here, just because they're produced slightly differently. I can tweak the spectrogram settings a little bit to kind of make this either lighter or darker. That might match up a little bit better to what you see here in this representation. Either way, what I want to do here is just kind of point out to you where the formants are in these vowels in case you have a hard time finding them. And then I'm going to take measurements and actually kind of start to plot out a vowel space like you did for your third production exercise. That's one way to kind of figure out, sort of back engineer what vowels are being produced in each one of these spectrograms. So just looking at this image here, this one's actually a tricky one to start off with. I don't know what I was thinking when I created this exercise a while back. Maybe I should change it, but as it is, it helps a little bit because you can see that in this particular vowel, there's this one kind of massive formant here down at the lower end of the frequency range to begin with. And you can see that it's not really one massive formant. It's actually two that are coming together here. You can see them split off at the end of this production. One goes down, F1 goes down, F2 goes up. So in the middle, they're kind of glommed together, and then we have F3 up here, but we're not going to worry about F3 today so much. But I'll kind of try to help you out here by measuring these, and it's a bit of a bit of guesswork here. This is a nice high quality recording, so we should be able to get decent formant measurements off of this thing, not too difficultly, if that's a word. But this is F1 here. I'm just kind of picking a spot in the middle of the vowel and also trying to pick a spot in the middle of this first formant. It's about 950 hertz, maybe a little bit less. F2 is about 1376. I'm going to put this in little spreadsheet. I was actually trying to do this in a genuine spreadsheet like in Excel. I was having so I can generate formant plots out of that. I was having a hard time generating the formant plots using this program called R from that, so I'm just going to do this in a text file. You don't have to worry about the technical details so much, but that's what's going on here. I'll show you in a second how you can interpret those. But I'm just going to make measurements of F1 and F2, and I'm also going to stop and pause before I get too far into that and just remind you that sort of our default F1, F2 values for, say, a male speaker of English who's about my size, the vocal tract my length, would be about 500 hertz for F1, 1500 hertz for F2, 2500 hertz for F3, so on and so forth, all the way down the line. So 500 hertz for F1, 1500 hertz for F2 puts you basically where schwa is in the vowel space. So that's somewhere in the mid-central portion of the space. If you have an F1 which is lower than that, you're going to get a high vowel. If you have an F1 that is higher than that, you're going to get a low vowel. That's kind of the counterintuitive relationship to remember, that low F1 means high in the vowel space and high F1 means low in the vowel space. But keep that one in mind to begin with. And then F2, if it's lower than 1500 hertz for somebody my size basically, then that's going to be a back vowel. And F2 is high, then it's going to be a front vowel. So we can already kind of get a sense here. This is a female speaker, like I said, so likely her kind of default point in the space acoustically is going to be higher in both dimensions. So rather than 500 and 1500, it might be a little bit above that, like 600 or 700 as a default value for F1. Maybe something like 1700, 1800 for F2, something like that. We'll find out in a moment just where her kind of default value is when we make these measurements. But just keep that in mind. We can look at this first set of measurements and say, well, F1 is about 950 hertz. That's definitely higher than the default value you'd expect to have for a speaker of English, or an adult speaker of English. So if that's higher, then that must be a low vowel in the space. That's the counterintuitive relationship. And then F2 is 1376. We said this speaker will probably have a default F2 value of higher than 1500 hertz. So this is definitely lower than that. That means that this is a back vowel. So we have a low back vowel here, low determined by F1, back determined by F2. And we get this kind of classic low back look in the spectrogram itself, such that this is F1 and F2 coming together. That's what you typically see for a low back vowel. So really kind of straightforward guess you can make for this particular one is that it might be a vowel like ah, or in Canadian English slightly rounded like aw. Like aw, what a cute little puppy. So something like bod. And I'll turn that up so you can hear it better. Bod. B-A-W-D, basically. So we'll leave that as it is, but that's the answer to number one, which you found out if you've actually done this, but it's the second one here, B-A-W-D for spectrogram A. And it's just occurring to me that I should probably keep score for this somehow. I might actually, I was trying to do this before. Do it differently. All right, I might edit this out, or I might not, depending on how much time I have today, which is not much. Okay, so we're going to guess bod for that particular spectrogram, and leave it like that. Let's move on to spectrogram B. This one might be a little bit more ambiguous, but here's F1 down here. It fades in and out a little bit. That's mostly a result of her changing pitch of her voice. This is F2 up here, kind of pops up and then goes down a little bit. So what's up with that? We can look at it in prod and see what it tells us. But we can see that pattern again here. Actually, I'll check out what the pitch does. It kind of bounces up and bounces up and down a little bit. You can kind of see this blue line gets mimicked by this fading out line down here. There's technical reasons why that's going on, but that's the reason why you see that. You can also see it as it goes up the scale here. It's a result of the harmonics underlying the formants. We don't really worry about the harmonics so much here. We're going to worry about the formants. So I'll turn off the pitch tracker and let's take a look at F1 and F2 here. So F1, it's kind of hard to read because of that fading out, but it's maybe about 518 hertz, something like that for spectrogram B. And then for F2, we have 2301, something like that. So go back again to what I said earlier. Maybe I'll keep score here on this spreadsheet, but so if I expand this a little bit, like my default F1 is going to be 500. This is like for schwa, right? It's 1500 for F2. So if I do greater, maybe I'll do it like this, greater than and less than. So greater than 500 would be a low vowel. And if it's less than 500, then it's high vowel. So that's again for me. And it's going to be slightly different for an adult female speaker, most likely, like the one we're working with here. But that's the relationship, right? And then if it's greater than 1500 for F2, then we have a front vowel. And if it's less than that, then it's a back vowel. And I can kind of tweak this a little bit so you might be able to see it better. Again, normally I write this stuff on the board, but we're adjusting here still to this day in the midst of this weirdness. Anyways, let's say adult female speaker. The only difference here is going to be where exactly this sort of default value is. So 500, 1500, this is what you'd get for like a schwa, right? That's kind of our default vowel. And we can do the same thing here, but it's not going to be exactly 500 and 1500. So we might make a guess and say like maybe 600 would be a default, maybe 1800 because it's 3 times that for F2. Something like that. It's going to be a little bit higher in both cases, but the same relationship will hold. Whatever sort of the default is for this speaker, if it's higher than that in F1, it's going to be a low vowel. If it's lower than that for F1, it's going to be high, so on and so forth. So just keep that up there as a reference frame we can work with and try to figure out what we're dealing with here. So our F1 for Spectrogram B is 518. It's higher than my default for F1. Maybe it's lower than this speaker's default for F1. So we don't really know for sure. We might say that's kind of a highish vowel, maybe. 2300 though is definitely going to be higher than F2's default for both cases. That's pretty high F2. So it's highish and front, basically. So we don't know exactly where that's going to put us in the space because there's more than one high front vowel. We'll just take a look at this again. I'm not going to make a guess right now, but what I will do is plot this thing. So I've got some code here for this statistical software R. And hopefully, oops, I got to change my working directory. Hopefully I'll be able to get this to work. No, I do got it in the right spot. So we're just going to read in these values that I'm typing in here. And I've got this complicated looking vowel plotting formula, which I'm going to enter into R, and then it's going to spit out a graph that looks like this. So I'll tweak this a little bit so you can see the axis labels. But it's basically telling you the same story I was giving you with this sort of reference frame, I think is what I called it. Rule of thumb, you might say, for how to interpret F1 and F2 in these spectrograms. But basically, A, which we decided was like a vowel like ah or aw, is low and back. So just to make it clear, the reason it's low and back is because of how I'm plotting F1 and F2. So F1 is plotted in the vertical dimension, in the opposite orientation we normally think of, where 0 is at the top and then the numbers increase as you go down. Because of that, higher values of F1 become low vowels and lower values of F1 become high vowels. So we can see also for F2, the 0 numbers are on the right, or the closer to 0 numbers on the right, and then they increase as you go to the left. Again, the opposite of how these things are normally plotted in a graph that you might have learned about in math class. But that gives us the orientation we're looking at, because the orientation we want to look at, because this is a, aw, down here in the lower right-hand corner of the space. It's a low back vowel. And we said B is like highish front, maybe, right? So it's definitely fronter than A here, and it's higher than A as well. We just don't know exactly which particular vowel in the high front corner of the space this one happens to be. Okay, so I'm going to leave it like that for now and not make a specific guess about B, but we'll just say high front. Maybe we'll put this in brackets or something. Okay, good. So that's working. We got 11 more to go. Hopefully it won't take too long once we get the hang of it. But let's take a shot at sound C and find out what that looks like. Okay, right, so we see this in here as well. And here is the point at which it's useful to pay a little bit of attention to dynamics. So, like this one, I can make another format plot of this if I want to, and say, well, F1 at the start here is something like 950 hertz, and F2 is something like 1750 hertz, maybe. Hopefully you can see that in the video, but that means that that's going to be a high F1, which makes it a low vowel, and it's a high F2, a highish F2 as well, so it's going to be a frontish vowel as well. So I can put that down, high frontish maybe. something like that. But then you see that these format values change, right? So F2 goes down. Maybe it's going to be easier if I turn on the format tracker. But you can see F2 goes down as we go towards the end of the vowel, and then it kind of pops up when we get into the consonant. You don't need to worry about that. That's just moving your tongue to make the D at the end. F1 goes down as well. So what's going on with that? Basically, if you see these formants changing in some meaningful way over the course of the vowel, it means you're dealing with more of a diphthong than just like a monophthong pure vowel. So both of these are going down. What does that mean? Well, we're starting off in sort of a high front. Sorry, did I say high front? I meant low. Sorry. Low frontish corner of the space. Too late to edit that out. And then it goes into something like the high back corner of the vowel space. So if I go back to R, hopefully we can kind of visualize that. We're starting out at something like 950, 1750, maybe somewhere down here. And then both of these values go in this direction. I'm sorry I can't like draw that out. But it goes from here to here. Maybe I can give this a shot actually. Maybe I'll do it like this. There's nothing like trying something new on the spur of the moment. But this is going to be low frontish to higher backer. And we'll just plot it out. So what did I say? Like 950, 1750? And we'll say C1 and C2. So let's make some more format plots here at the tail end of this thing. Make maybe around here. And F1 is something like 670. And F2 is 1290, something like that. Okay, and we're going to run these same commands here in R, and we're going to get a different plot. It didn't pop up, but it's there. Yeah, whoops, didn't turn out the way I wanted it to. But basically, I wanted it to say like C1. I see why it's doing that. Okay. Don't know if there's a way around that. Anyways, it's starting out here. And it's going here. So this is ah. This is our low back part of the space. And this is fronter than that, but still is low in the vowel space. So because it's going from this low front portion to the higher backer regions of the space, a good guess of that is like a diphthong like ow. So that would be something like bowed. And if we play it,
Bowed.
We're rewarded. I'm going to turn these all up a little bit. I don't know if I've shown you this in videos for class at all, but if you highlight a sound in Prot and go to Modify Scale Intensity, you can make them whatever intensity you want. I'm going to make them 70 dB in this case. We'll play that again.
Bowed.
And you still can't hear it, so I'm going to make them even louder. Oh, I might not be able to tweak the sound. We'll find out now that I started the video, but let's give this a shot.
Bowed.
No, there it is. Good. Okay, so yeah. Yeah, we'll just leave both those in there because why not? And hopefully we can remember the connection between them or the direction of the two. Let's go to Spectrogram D. Okay, so Spectrogram B you can kind of cheat a little bit with, and hopefully you notice this as you're doing the exercise. But we can look again like at what the specific values of this, the formants are in this vowel. This is the vowel part of it. Like we have a lowish F1 here of like 500. And then like this is clearly moving, right? So you could pick a spot in the middle if you want to and say 1530. But you can also sort of treat it as a diphthong maybe and say, well, it's like 1238 at the start. And that's D1. And we'll say D2. And F1's not really changing much here. It's kind of about 500, maybe a little bit lower than that all the way through. If I measure it at the tail end, then it looks different, right? So F2 definitely went up for some reason. So that's what I've got there for the vowel measurements. But again, the cheat here, or actually, I didn't make this explicit before. The cheat is like, this clearly looks different here at the start, right? So with all these others, we see these individual little pops, these little release bursts, which are the release bursts for the stop at the beginning of the word, the buzz. I'm not getting those here, though. I'm getting something else, which is turbulent and messy. You may not have known this at the time you're doing the exercise, but that looks like a fricative, and in particular, it looks like an H fricative, right? Like for hood, which is the only one of these that doesn't start with a B. So we can kind of cheat here for this one and just say, well, this is clearly an H. I can see this kind of formant structure here at the beginning, especially for F2, a little for F3, F4 as well. But I'll just make that guess and listen to it and find out that I'm right.
Hood.
Right, because I've looked at a lot of these, but that's what an H looks like, and that's what it sounds like. You just play the H part. We can plot where those vowels are, and we'll find out something as well. Yeah, so it's kind of going from the back of the space to the front of the space, right? F2 goes up. And that's what it looks like if you plot it. We can listen to it as well. Take the first part that we measured before. And that's kind of that vowel, that high back lax vowel that we're expecting here. But this one at the end should sound different. Like maybe more like an I, like a lax front vowel. High lax front vowel. So is basically what she's saying here. Hood. So hood. In context, it probably sounds perfectly normal to you. When you actually focus in on the details, out of that context, you can kind of pick up on the fact that she's making that into more of a diphthong than we normally refer to it as. But that's what's going on there. Let's go to E. Don't want this to take too long. So E is kind of funny. You can see it in both representations here. Let's do the measurements here. And then plot where this thing might be. So this one's, again, 484. So lowish F1 means we're in the high region of the space. And then F2 is about 1564. We don't know exactly where the speaker's kind of default value is for F2, but this seems to be kind of in between front and back, right? So for we had 1238. When that moved forward to it was more like 1941. Excuse me. This is kind of halfway in between there. That puts you kind of in the central part of the space. And we can plot that again to get a sense of what that would look like. And then this is what I do without chalkboard at my disposal, but here's E, right? So A was bawed. This is bowed with the ah at the beginning of that diphthong. Ow. Ow. And this E is in the middle of that. But it's in the high portion of the space. I'm going to leave that for now and say E is high central. Like what? What's going on there? And not make a determination about that until we see a few more, what a few more vowels look like. So just keep that in mind. That one's funny, but it looks like it's evenly spaced, which is what I told you the case was for schwa. But it's high rather than mid. So that's not exactly where schwa would normally be. All right, just keep that in mind. We'll move on to spectrogram F. And at this point, this is where the measurements kind of really help you out because we're dealing with a lot of different vowels. And it's hard to know exactly which one's going to fit in where when we're trying to figure out what these things are actually saying. So here's F. My F1's a little bit higher than what we've seen before, so 655. And here's F2, 2096. So that's high as well. So, right, we can kind of look at this with respect to some of these other vowels. It's not like a super high F1, so it's not like a super low vowel by any means. F2 is relatively high, though, so it's definitely front. So you might say this is kind of a midish. Oops, didn't want that. Midish front vowel. Yeah. So what does that leave us, right? What's in the mid front portion of the space? It's staying at relatively the same formant frequencies all the way through. We can plot it and see what that looks like. Maybe that'll give us a hint as to what we're dealing with. But now I'm around here. So this is my F. And what I will guess, because it's not really a guess, I know the answer, is that this is going to be a midish front vowel like like in the word bed. So we can play that one.
Bed.
And that's what we get, right?
Bed.
And this is helping now. We're getting more and more reference points to work with here. So this is this is a, and like ow. This is aw. This is our and this b we still don't know the answer to, but it's higher in fronter than an so something like that. But yeah, maybe the mid-central portion of the space, probably around here for this speaker, maybe a little bit lower. Okay, let's keep rolling. Let's see what G gives us. Right, so this is a fun one. There's a little action here in the diphthongs at the beginning, obviously. So that's good to keep in mind. But let's measure formants here from the middle because they look fairly stable after that little blip at the beginning. So this is F1 of 1033, which is pretty high based on what we've seen before, in 1856 for F2. So both of these guys look high. So F1 is high. That means we have a low vowel. F2 is high-ish. That means we have a front or frontish vowel, right? So let's go back to our little guessing scoreboard, and we have a high frontish vowel. Or sorry, not a high frontish vowel, but a low frontish vowel. Something like that. Okay, so what does that mean for our purposes? We can plot this again too to get a sense of where it fits into the system. But G is down here in the very low front region of the space. So I said this C, where C began was like this is kind of lower in fronter than that. Hopefully you can figure this out based on what you know about the vowel space in general, but this is like in the word
Bad.
bad, like that. So in particular, we see the distinction. We can compare it to like So like a lot of non-native speakers of English have difficulty separating these two, bed and bad, because they sound fairly similar to what most languages have for a vowel in this space, both of them together. But they're distinct in this variety of English, at least.
Bad.
And F, the way we can kind of figure that out is F1 primarily is a lot higher for than it is for the and then F2 is pretty close, but it's a little bit lower for the vowel, which makes it a bit of a backer vowel. We can see now this is where we are for the low portion of the space pretty clearly. Let's keep rolling before this takes an inordinate amount of time. Here's H. This is a nice sort of stable looking vowel. Let's get some measurements here. My F1 is maybe about 501. So that looks relatively low for this speaker, which makes it a high vowel. And my F2 is pretty high, 2507. So now I'm in the high front portion of the space again. So I didn't make a determination about B yet, and for H, I'm going to be kind of winding up in the same spot, high front. Let's plot this and see if we can kind of figure out any difference between the two, and take a look at that. So here's H, here's B. They're pretty close. H looks like it's maybe higher in fronter than B, so maybe this is more of a tense vowel than B. I don't know. Let's keep going until we know for sure. So with that in mind, I guess I'll also point out this is relatively like stable formants, so maybe that's a clue as well. But let's take a look at I before we go any further with that. So I is nice because it looks like another diphthong. We've got movement in both F1 and F2, and we can kind of plot both parts of this, I think. So we'll do I1. We'll say it's 946.9, whatever, we've seen that before. And then F2 is 1393. So this looks like what we saw at the very beginning, right? With our vowel for A. It's something like that. It's almost an exact same spot. And then for I, the second part of it, F1 goes down. If F2 is going down, that means we're getting higher in the vowel space, so something like 672. And if F2 goes up, that means we're getting fronter in the vowel space. We're at 2147. So we start with ah, which is low back in the space, and then we get higher in fronter, because there's kind of like no way to get lower and backer with this. So we go I, something like that.
Bide.
And that gives us the vowel bide. Yeah. And we can plot those as well if you want to see how they move around. Yeah, it's kind of, it got plotted over the A here, but it goes from I like this, I, and maybe I, depending on how you measure that, but it winds up in the same spot as that we saw before. Let's listen to this last bit. Yeah, to me it sounds like A, maybe more than but in that general region of the space.
Bide. Bide.
Bye. Yeah, but that's a diphthong as well. Let's go for J. We've only got 4 more to go, and we're doing so well. Should be getting super confident at this point, if you've stuck with it all this time. But this is another diphthong, and what's going to be different here is what's going on in the first part of this guy. So we'll do J1 and J2. So F1 looks a lot lower than it did for I1, and then F2 here would be something like 981. So that's a lot lower too. So we're lower in both dimensions, which means that we're higher and backer in the space than we were before. And we can compare that to what's going on in the second part of this diphthong. So F1 stays pretty much the same, which is interesting. And F2 moves up considerably. So basically with, let's see, 550, 586 hertz for F1, we're slightly lower than you might expect for the default, wherever that happens to be. So this is a highish vowel, I guess I would say, all the way through. And then we go from 980, a low F2, we go from a back vowel to a front vowel. One way to kind of think about that, maybe I'll plot it so you can see it, is that we're kind of getting like an oi type vowel. So J goes from here to here. Remember I said the I sounds like it winds up in like an A spot, and F is like eh. This is maybe going to wind up in like an A type sound. Maybe the oi. It's supposed to be o, open O, oi, something like that. Because I think she started saying more an O here rather than an open O. It's close. That's an A at the tail end. Boyd is the word or name that she's saying there. That's a diphthong as well. Okay, what do we got? We got KLM, Dutch airliner, to end up or finish off this exercise. What is K? Well, this looks interesting as well. We got a little bit of movement in the diphthongs. Let's measure where they are in the middle. Maybe that'll tell us something. But we've got K here for, what was that, 826, something like that. Yeah, I mean, as you may have already known or figured out from the format measuring exercise, it's trying to be this precise with these numbers is not that useful in terms of like decimal points or whatever. Just, because minor little difference here can give you from 1684 to 1701, whatever. The general idea where these are, though, will be useful. So let's plot K. Where are we in the space now? Kind of mid-ish, right? So 826 for F1 is maybe on the high end for this speaker, so it's kind of a lowish vowel. 1684, though, is probably somewhere in the middle. We thought 1564 for F2 for E was making this essential vowel. This is maybe kind of a central vowel as well, but it's also kind of on the low side. So what we might get out of this is kind of a low-mid central-ish vowel, which is probably what we get for wedge in a word like
bud.
So this one kind of moves around a little bit too. Like F2 in particular, it's backer or it's lower at the start. and then it moves a little bit forward. So that's maybe, if you measure in the middle, maybe that's why she's here. It kind of probably moves forward like this in this low mid portion of the space. So it starts out maybe a little bit more like and then maybe more like an here at the end. If you can hear that. Yeah. But that's that word, at least. We figured that out. What do we got for L? Let's take a look. Well, we have two relatively low-looking formants compared to what we've seen so far. We'll make a guess for F1 is F535.5. F2 is 1255. So that's not very high at all. If we plot L, we should see it in that high back corner of the space, right up here. Yeah, and it's looking a lot like what we got for D at the beginning of D, which was our vowel, right? Yeah. So we're in the neighborhood of like the there in the high back region of the space. We're also close to where we started out with Boyd, that diphthong. Yeah, so this seems like it'd be a good candidate for a high back vowel. It's going to turn out to be the O vowel. Let's play it.
Bode.
Which I've told you is a diphthong. We don't see much of the diphthong movement here. What you kind of want to see is a little bit of a lowering of both formants as we go through it. You kind of see that for F2 more than F1. You kind of see this guy going down. Maybe I'll turn on the formants a little bit. Maybe a little bit for F1 as well. You can kind of see that decreasing by the end. So this should sound maybe a little bit more like an O. And this more like an U. Hopefully you can hear that. Something like that. Bode. But it's not like a really dramatic diphthong in this context for the speaker. And I think this leaves us one more, which maybe we can figure out. No, we can't figure out yet because we haven't gotten all the answers yet. But our last vowel is vowel M. Let's see what that looks like in spectrographic view. Yep, I've already turned on the formant tracker. I'll turn it off to get a different kind of look at this. But here's our F1, 432.6. And here's our F2, way up here at 2747. So this is the lowest F1 we've seen so far, and it's the highest F2 we've seen so far. That means it's a really high front vowel. And that means that we can think of it as the highest frontest vowel we've got in the English vowel system, which is the E, like in a word like bead, right?
Bead.
And that's kind of why I waited all this time to make a determination about these other high front vowels, because I knew this one would turn out the way it did.
Bead.
But that is helpful because it gives us kind of like a landmark by which to interpret everything else. Here's our completed vowel space now. We can kind of fill in the blanks, but here's M. This is E. And we've got a few others that we haven't figured out quite yet. We've got B, we've got E, we've got H. So here's E, here's H, here's B. So neither H or B, which we both called high front vowels, is E. They've got to be something else. I mentioned when we talked about the measurements for H that H is further out towards the periphery of the space. That might mean that it's more tense than B. You never know exactly for sure. What you kind of want to see for the A vowel is kind of this more of a diphthong-y pattern. A kind of the vowel moving towards that E, low F1, F2 pattern as you go through it. This is the pattern we see for B. Starts out with a higher F2 and then that F2 becomes lower, which means it's not moving fronter, it's moving sort of backer. F1 is kind of stable throughout. We can compare it to H. And this one, like I said, when we looked at it, it just seems to be stable all the way through. So it's not really a diphthong in any way. But another thing you look at, maybe we can see this in the original handout, is the length of these guys. That's not going to help either. Anyways, because B is becoming more of a back vowel, it's highly unlikely to be that A diphthong. which you would expect to move fronter. Instead, and it's also a little bit closer to the center of the space anyways, it's going to move from here kind of a little bit in this direction. It's that vowel I,
bid,
as in bid.
bid,
Yeah, so there's lots of little clues you can kind of look at to make this work or figure out what's going on. Stop that. Yay. And that means that our H is probably going to be bead, or sorry, bade, whatever that means. Let's go back to it.
bade,
Yeah. And yeah, this particular speaker of Canadian English
bade,
apparently has more monophthong vowels. Not to out her, but she's currently a professor at the University of Alberta now. So that has not gotten in her way of career success by any means. And lastly, we've got E here, which may surprise you, but it's what's supposed to be the oo vowel.
booed, booed,
Like in booed, they booed the Edmonton. No, they booed the Calgary Flames in Edmonton. Whatever.
booed,
So what's going on here, we can check back here in the space, is that F2 of oo has moved higher. It's become more centralized as a vowel. It's oo as opposed to oo.
booed,
Booed. Maybe not quite as much as I'm doing it there, but that's typically how oo is pronounced in modern day English. But anyways, that's how you can figure out what each one of these spectrograms represents, at least for starters. And this is kind of the vowel space you wind up with here. It's a little bit of a mess because we plotted some of these as diphthongs, but you can kind of see this quadrilateral shape a little bit, maybe a little bit of a triangle as well. Now that you've seen your own vowel spaces, you can kind of mix and match to see how they compare. But plotting out formants like this is a really useful way to try to do one of these matching exercises because there are so many vowels in English that we have to worry about. But anyways, keep in mind F1 and F2, remember the patterns there, that's important. And if you see that sort of those movements in F1 and F2, those can be informative as well in terms of trying to figure out if a vowel is a diphthong or where it's moving in the space. Lax vowels tend to move more towards the middle of the space. Tense vowels will tend to move more towards the outer or periphery portions of the space. I think I've said enough now, but hopefully this helps you figure out how to do this exercise. And if you haven't done part 2, you can always try it again with this method and maybe it'll go a little bit better. Actually, the last thing I'll say is that this is difficult for everybody the first time they try it. Most people don't get more than like 30 or 40% correct, maybe even less than that. So if you got any of these right, good on you. If you got vowels sort of in the same appropriate region of the space, even better. And we'll keep working on it as we go. But hopefully this is helpful for now. Okay, see you next time.